Right, so now we're gonna start from the beginning. We have discussed everything through the guidelines, but here we are going now deep into the content, right? So like I said, you need to know how to define your acid, you need to know how to define the base. Now there are two theories that were postulated in terms of definitions. Now, how to define acid and base according to Arrhenius' theory. Arrhenius suggested that acid produce hydrogen ions in a solution, and then the bases produce hydroxide ions in a solution. And then later on, two scientists came along and then they postulated this definition of acid and base. Now, the reason why these two guys came along is because now these definitions are more properly explaining how does an acid and a base actually react. Because here, according to Arrhenius' theory, when we look at the base, some of the bases they behave in such a way that they actually do not form hydroxide ions in the solution. So it's more or less like we have exception on how base react by the theory that was discussed by Arrhenius. And in these two guys, they realized that no, actually base is a proton donor, and each and every base, this is how it behaves. So Arrhenius was not wrong. It is just that it doesn't um, include all of the bases on how they actually behave, the mechanisms of how other bases behave. Okay, so this is 1000% on how all of the bases behave. So these guys, they came along, they didn't see anything wrong with Arrhenius, they just wanted to give a more proper explanation of acid and a base. So you should be able to know how to define them. Now, here it is a demonstration of how these theories actually were postulated. Now, firstly, let's look at the Arrhenius theory in terms of acid producing hydrogen ions, like how he said it over there. Now, in this case, we can see that in this example, we have uh, HNO3, which is our acid. It's a nitric acid. Nitric acid, it forms H plus ions and NO minus ions. Most of the time, this happens when this acid ionizes in water. So when this acid ionizes in water, then what's going to happen is, because remember, he said that they produce hydrogen ions in water. So it will react with water, and then we're going to have H plus ions in water. Now, these H plus ions in water, they simply indicate the concentration of acid. Okay, that's an Arrhenius theory. Now, let's talk about the base. We can see that we have KOH, and then it forms K plus ion and OH minus ion. So here the highlighted is H plus ion, which is this, but here we can see that we have OH minus ion, which is this, right? Again, if this dissociate in water, we're gonna have these two products that we see over here. So the OH minus ion, it is an indication that the solution, it is basic. So that's how we actually can demonstrate this theory that was postulated by Arrhenius. Now, again, like I said, two guys came along, which is Lorry and Browstead. They postulated that an acid, it is a proton donor, and a base, it is a proton acceptor. What is a proton? It is hydrogen plus ion, H plus ion. We call it a proton because it doesn't have an electron. Remember that from the chemistry level, we have learned that hydrogen can either behave as a hydrogen can behave as a metal or a non-metal. So if it behaves as a metal, it will have to donate the electron. Then obvious, hydrogen has one electron, one proton. So if it donates that electron, it remains behind with the proton. So in this case, then we call it a proton. Okay. All right. So Lorry and Brostad. Now let's have a look at this chemical reaction. We have acid, we have a base. We have an acid, in this case, our water, it is called base. Acid will have to donate its proton, right? Will have to donate its proton. So when it donates its proton, then acid, which is NO3, it will turn into NO3 minus ions. And then the base will turn into H H3O plus ion because it has accepted the proton. That's how these guys came along to postulate the definition of these terminologies. And then furthermore, according to these guys, you can see that, but like how if you go back to the exam guide, the guidelines, the one that we started with, you could see that H2O was able to behave as either acid and a base. And I said the terminology that we assign for H2O, it is called the enfolite. Okay, right. Now, for 3.5, now we're gonna discuss the strengths of acid and base. Like I said from the guidelines, when we talk about a strong acid, we use the word completely, meaning strong acid, it ionizes in water to form high concentration of H3O plus ions because it is strong. So when it is strong, it has high concentration of hydronium ions in water. But when we talk about the weak acid, we say it ionizes incompletely, or you can say it ionizes partially in water to form low concentration of hydronium ions. It makes sense, right? The strong, completely, the weak, incompletely. And then same applies to the strong base in terms of dissociation. The strong base, we say it dissociates completely in water to form obvious, again, high concentration, but now because it's a base, it will form a high concentration of hydroxide ions in a solution. But a weak base, it will dissociate, or again, you can use the word ionize, incompletely or partially in water, now form low concentration of OH. So the whole idea over here is strong completely and high, weak incompletely and low. Whether you are talking about the acid or a base, then that's when you have to differentiate whether it is hydronium ions or yeah, it is hydronium, or you can call it oxonium ions and hydroxide ions. Okay, right. So, like I said from the guidelines, I said there are many different types of acids. There are many different types of bases. Some are strong, some are weak. And we have just discussed how strong acid react. We said that strong acid, during the reaction, they will ionize completely. And then we're going to have high concentration of H3O plus ions. Now, here it is more or less of a demonstration on how this acid actually works. Now, what I want you to have a look at is we have our acid, and then we have the H plus ions, right? So if our acid is ionized completely, look, this, it is the presence of acid. Do you see something that looks like this in the container? No, the only thing that you see inside of this container, it is this and this separated. There is no combination of here. What does that mean? That means in this solution, there is no acid and base that there is no, sorry, there is no acid in this solution. The only thing that you will see are the ions of that acid. So why do we see only ions of the acid? Because it is a strong acid. It has ionized completely in water, hence why we cannot see it 100% ionization. That's why we cannot see this thing inside of this solution. But when you look at the weak acid, we still do have this, which is this, which is this, which is this, which is this, and which is that. And then here are the ions. Here's the ion, here's the ion, here's the ion, here's the ion. For a fact that we still have these two guys that are held together, it's an indication that in this solution, What type of acid do we have? We have a weak acid because it ionizes incompletely. You get my point? So sometimes in exam, they can give you diagrams like this, and they ask you diagram A or diagram B has a weak acid. You should be able to spot it out by just looking at those diagrams, which one has a weak acid, which one has, by looking at this combination. Okay, so this is just a way of how to show these definitions that we see over here for a strong, weak acid, strong, weak bases. Okay, right. Now, we have already spoke about this, but now what I want us to do over here is I want us to look at this table or the list of acids and bases. So I think there's seven of them. Sure, one, two, three. Okay, four, five, six. But yeah, it's fine. For matriculants, they're not gonna ask you anything out of this table. Okay, let's you get to universities and you do more of um acids and base reaction. You do more of physical chemistry, but you are doing physical science, which is in grade 12. So these are only type of acids and bases that they can ask you about. So we have the strong acids. Here are the names of the ones that you should. That's why please familiarize yourself with this list or table given below because they're not gonna tell you which one is a strong acid, which one it is a weak acid, which one is a strong base, which one it is a weak base. You should know them by yourselves. So HCl, HN, HNO3, H2SO2, H3PO4. These are all strong acid hydrochloric, which is monoprotic. I have explained what does monoprotic mean, meaning it donates once. And then another monoprotic, it's nitric acid. We have sulfuric acid, which is diprotic. How do you see that it is diprotic? Because it has H2, meaning it will donate two protons. And then phosphoric acid, it is triprotic, meaning it can donate three times. Okay, so how do you see that this is a strong acid? If it starts with H, can see that it starts with H, then it is a strong acid. Here it is though we do have H, which is a weak acid. We do have H, but it doesn't start with H. So these are a type of acids, but we call them the weak acid. So here we have acetic acid, and then here we have oxalic acid. Okay, if you have a look at this, you did organic chemistry. By now, you should be able to know how to name this, right? This is carboxylic acid, CH3COOH. This is just a common name. You can give the scientific name of this, which is ether ethanoic acid. Acetic acid, it is the same as ethanoic acid, right? Organic chemistry. We have one carbon, we have another carbon over there, one, two, three hydrogens. We have oxygen over here. We have oxygen over here. We have another oxygen bonded with hydrogen. You see, core that has a strawberry on top. So this is carboxylic acid. How many carbons do we have? One, two. Ethanoic acid. This is ethanoic acid, or you can call it acetic acid. So ethanoic acid or acetic acid, it is a weak acid. Even the oxalic acid, it is a weak acid, right? So it doesn't start with H, so it can't be a strong acid like these ones that we see over here. Now, let's come to the strong bases. Strong bases, it's an AOH, KOH, LiOH, BaOH2. So, sodium hydroxide, potassium hydroxide, lithium hydroxide, and barium hydroxide. And then the weak bases is ammonia and zinc hydroxide. Now, when you look at the strong bases, they have OH, 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 OH. Exception, it is the zinc hydroxide. Always remind yourself like that. If it has OH, OH, OH is a strong base, except this one because it has OH as well. So these are all strong acids. Sorry, strong bases. But the weak bases are the ones that follow below, which is ammonia and zinc hydroxide. By the way, ammonia, it is a weak base, like how I discussed it under the guidelines. Okay. So please familiarize yourselves with this list of substances. Like I said, monoprotic acid is an acid that can donate only one proton, but diprotic can donate maximum of two protons. So examples, we have HCl. Example, we have H2SO4. We can see that we have H2, it's diprotic. Like I said over here, this is diprotic because it has H3. Okay, so that's how we can spot it. So here we were actually discussing what? The strength of a strong and the weak, right? So that was 3.5. Now, 3.4, we're going to talk about the concentrated, diluted. Like again, like how like I said, now we're going deeper. I said to you, whether you have a strong acid or you have a strong base, if you add more water inside of that acid or inside of that base, you're not gonna change its strength. The only thing that's gonna change, it is the concentration. Take your beaker, inside of your beaker, you have water, you add hydrochloric acid. Hydrochloric acid, it is a strong acid. You put it inside of your beaker that has water. What's gonna happen? Ionization, right? So if you continue to add more water, maybe in your mind you will be like, I want to add more water so that this acid it becomes weak. No, whether you add 100 milliliter of water, you add 200 milliliter of water inside of it, it will remain as a strong acid. The only thing that's going to change it is the concentration. Do you understand? So always bear that in mind. So when you concentrate or when you dilute either acid or a base, we are talking about the volume of water and the substance, which in this case it is the acid. If you have more water than acid, then it is diluted. If you have less water than acid, it is concentrated. You guys do this juice that you buy at the shop. One of the examples, Wild Island. Wild Island will remain Wild Island. Whether you add more water or you add, the only thing that you can change it is the concentration. If you add more water inside of your syrup, then it's gonna be diluted. But if you add less water, it's gonna taste very sweet, meaning it is concentrated. Right? So that's how it works. So when something it is concentrated, whether acid or a base, what does that mean? That means we have a large amount of moles of acid or base in proportion to volume of water. When it is concentrated, you have more of it than water. But when it is dilute, if you dilute acid or you dilute base, that means you have small amount of acid. You have small number of moles of acid or base in proportion to volume of water, meaning you have less water but more you have less acid. Let's talk about acid alone. You have less acid but more water. That's a dilution. Okay, so that's what we mean by concentrated, not the strength. The strength will remain the same. Sometimes they ask those questions, choose greater than, less than, or equals to, or remain the same, or whatever. They ask you that you have hydrochloric acid. When you add more water in hydrochloric acid, will the strength of hydrochloric acid remain the same, increase or decrease? It will remain the same. Whether you increase water, you decrease water, the strength will remain the same. If it is a strong acid, it will remain a strong acid, irrespective of how much water you pour inside. Okay? So here, if you have more acid, look, we have more acid, we have less water. That means here it is concentrated acid. But here we have more water, less acid. That means it is diluted. Okay? All right. Like I said, a dilute acid, it is not a weak acid. A weak acid can either be concentrated or diluted. Like I said, it's what I have already said. It's what I have already said. that the diluted acid, if you want, you say, no, weak acid, it's weak acid because it is diluted. No, you are lying. It is weak acid because it is a weak acid, not because it is diluted. A strong base, a strong acid, it is concentrated. No, you are lying. A strong acid is a strong acid because it is strong, not because it is concentrated. Because strong acid can be concentrated, strong acid can be diluted. So balance me over there. Okay, don't confuse these terminologies. Awesome. Now, the other thing that I want us to understand is, like I said, we're going to talk about the conductivity as well from the guideline. When I was explaining the guideline, I said that the strong, what you need to know is when it comes to electricity, recall that if you take your water, right, and then you say you pour your HCl inside of water, your hydrochloric acid, you're gonna form ions. You're gonna have form H plus ions and Cl minus ions. And we can see that this is the acidic solution because we have high concentration of hydrogen ions. Okay, so by the way, HCl, it is a strong acid. Do not forget that. When you ionizes or dissociate your strong acid in a solution, you're gonna form the ions. Now, this is what we have learned under electrochemistry. We have learned that the ionic compounds, when they dissolve in water, they form the ions. And those ions, they become good conductors of electricity. So even here under acids and bases, when you have a strong acid or you have a strong base, they will conduct electricity better than a weak acid. Why? This is a weak acid. Let me go back to that so that it makes sense. This is a strong acid. We do not have acid in a solution. Rather, we have the ions, right? We have the ions. We have the ions. That's a strong acid. A weak base, we still do have the acid, which is these ones that I have highlighted over here. And then we have less ions. So it must make sense why we say strong acid or a strong base is a good conductor of electricity, because we have more ions than in a weak acid. In a weak acid, we have few ions. It didn't dissociate, meaning our acid or our base did not ionizes completely. Here, our acid or base has ionized completely, meaning we have a lot of ions in this solution. That's why it is a good conductor of electricity, because of more ions in the solution. But in this case, weak acid, we have less ions, so it won't be a good conductor of electricity. Do you get my point? So that's why here we say strong acids conduct electricity better than the weak acids and bases because of the greater number of ions in a solution, since wara, which is what I have already explained. Okay? Awesome. So same applies to bases, and yeah. So that was 3.6. Now, before we get to complex stuff, calculations, let's talk about the conjugates. What are conjugates? Now, when we talk about the conjugates, we're going to look at the pairs for acids and bases, right? Like I said, when I was explaining the exam guideline, I said I will explain this much more better now here when we do the concept, okay? Now, what I want us to do is, I want to do it like this. Looking at this example now. Let's have a look at this chemical reaction. Remember, I said the reaction can be acid and water or base and water. That's aqueous solution or aqueous reaction. Or you can take your acid and your base. That's neutralization. And then now we go to hydrolysis. But okay, sorry, let's just be here for now. Now, this is your chemical reaction. This is your acid, and this is your water. I said to you, water, it is an N4 light. What does N4 light mean? It can behave as either acid or base. So what is a good N4 light? So when water reacts with acid, that means it will become base. When water reacts with base, then water will become acid. You get it? So water plays for two teams over here. Right. So that's an N4-lite, but not only water is N4-lite. There are other substances that are N4-lites. We'll learn that as time goes by. Now, look at this chemical reaction. Acid and base, and then here are the products. And by the way, this reaction, it is reversible. But most of the times, when you know why it is reversible, I want you to pay attention to something that is important, of which I know you guys don't even pay attention onto. The reason why this reaction, it is reversible, it's because of a weak base. Remember, ammonia, it is a weak base. It's because of the, whoa, that's not the base, it's an acid. Why did I say it's an acid? So ammonia, it will be the base, the weak base. Take that back. So this will be the base. Then water will be an acid. Right. So ammonia, it is a weak base. Ne? So we said that a weak base dissociate incompletely in water or ionizes incompletely in water. So when a substance ionizes incompletely, the reaction becomes reversible. Oh, by the way, I think it's written here. Forward direction, wara wara, reverse. Is it because donates proton, wara wara? Yeah, okay, it's fine. The reason why we have double arrows is because of a weak. But if it was a strong acid, HCl plus H2O, we do not do reaction like this. We do not use double arrow. You are lying. It's wrong. We use single arrow. We do not use double arrows. You know why you use single arrow? We use single arrow because it dissociate completely. It won't go back. It won't go back. So we do this. When you see this, that's another hint that I want to give to you. Sometimes I know you guys don't know whether the acid it is strong or it is weak. Look at this. If the moment you see this, just know you are using weak stuff over there. Okay? Right, sharp, fine. Let's talk about the conjugates. So this water will donate the proton, H plus ion, to our weak base. And then our weak base, which is an H3, will form ammonium ion because it has accepted the proton. And then H2O, it will turn into OH minus ion because it has donated the proton. Then we're going to have these guys over here. But because this reaction, it is reversible. So that means these two guys, they can react with one another to form what we see over here. So because this reaction is reversible, that means the reactants, sorry, the products, the products can react to form back the reactants. Meaning in this case, this guy will be the one to donate the proton. And who is a donator? A donator, it is an acid. So that means this is an acid. That means this, it is an acid. And OH minus ion, it is a base. It will accept that proton to go back to water. And an NH4 plus ion, it will donate its proton to go back to ammonia. So that means this guy will be acid, and this guy will be base, right? Because he accept and this one donates. So A, B, we call them the conjugate. This side, sorry, these guys over here on the product side, we call them the conjugate. Do you get it? We call them the conjugate base pairs. So the conjugate base pairs are as follows. So ammonia, he will tend to be ammonium ion. So who is the conjugate of ammonia? The conjugate of ammonia, By the way, we call him the conjugate acid. The conjugate acid of ammonia. The conjugate acid of ammonia is a base, but I want you to understand me. The conjugate acid in exam, you know what they can do? They can just say this. And they say, give the conjugate acid of ammonia. They say this is a base, by the way. Give the conjugate acid of ammonia. Here's the conjugate acid of ammonia. This is the conjugate acid of ammonia. It's going to be, this is an acid, NH4 plus ion. This is the conjugate acid. If they give you water and they want the conjugate base, this is acid according to this reaction. Water, it is the acid. If they want the conjugate, because they give you acid, you need its conjugate base. They give you base, you need its conjugate acid. You get the difference. So the conjugate acid of water is going to be OH minus ion. Okay, it's going to be OH. That's why here, what is the conjugate base of the following? The conjugate base of this guy is this guy. That means this guy, it is an acid. It's an acid. Its conjugate base is going to be this guy. Here's ammonia. I told you this is what we did over here. I said this is a base. Ammonia, it is a base. Its conjugate acid, it's NH4 plus ion, which is here. If they say determine the conjugate acid of what? Of ammonia, it's going to be this guy. This is the conjugate acid of ammonia. Because ammonia, it is a base. We are looking for his conjugate acid. Okay? Be careful on how to use these terminologies, because I know, guys, sometimes these terminologies can throw you off. Now you don't even understand what is the question looking for. So this assists especially when answering multiple choice questions. So be careful, okay? So to form a conjugate acid, oh, here it's all about formation. To form the conjugate acid, I get it, this is the conjugate acid. Look, this is ammonia. And I say to you, what is the conjugate acid? Automatically, you can know it just like that. Oh, the conjugate acid of ammonia is going to be NH4 plus ion. But sometimes you forget, which is fine, which is okay. If they want conjugate acid, just know that this thing is a base. They are looking for conjugate acid, meaning they are looking at conjugate acid of a what? Of a base. So when you are looking for a conjugate acid of a base, on that base, what you're going to do, you're going to add a proton. This is NH3. You add a proton to NH3, you form NH4 plus ion. Now, this thing, it is the conjugate acid. And this is a base, and this is its conjugate acid. Be careful on how you do this. Same applies whether they are looking for conjugate acid, you add. When they are looking for conjugate base, you remove. But if you know, you know. You don't even have to add and remove. If you know, because you practice a lot, right? So that's how it works. And then even here, this is how you can see those pairs, okay? So there is nothing complex about these things. Even here, they say identify conjugate acid-base pairs in the following balanced equation. So they want you to look for the pairs. So for number A, you have this guy, right? You can see literally this guy will tend to be this guy. Again, you have this guy. You can see literally this guy will tend to be this guy. So these are the pairs. These are most definitely your pairs. They pair up. They pair up. But this is the acid. Right? Let's see. Oh, it's a base. This is the base. because it will donate to form that guy. And this is the acid. It will donate to form OH minus ion. And then the purple part will be the conjugates. But the conjugate for who? You see? So that's how it works. Okay, so I hope that was clear. So that was 3.6 on identifying the conjugate acid-base pairs. So I explained one, it will make sense for all. You don't have to, you know the stereotypical, and I know that, right? Now we are going to talk about the hydrolysis. My favorite part. I said to you, acid, I repeat, acid can react with water to form whatever. Base can react with water to form whatever. Now, acid and base can react together always to form salt. And sometimes water will always be there, sometimes carbon dioxide. But like I said, these these products, they depends on what acid and what base are reacting. Like I said, we have different types of acids and bases. So the products solely depends on what is reacting over here. But the whole idea is salt will always be formed. And then again, when acid and base react together, it depends whether there's a strong acid and a weak base, or a strong acid and a strong base, or a weak acid, weak base, weak acid, strong base. It also depends. Now, when we talk about the hydrolysis, what are we talking about? It's a reaction of the salt that is going to be formed from acid and base and water. So here's the thing. I said A plus water, base plus water, this is aqueous solution. But when acid and base react, what type of reaction is this? We called it a neutralization reaction. We are neutralizing because we will always form water. But here, when acid and water reacts, you are not forming water. You are forming solution that is either, here's obvious, you're going to have H plus ions, and then here, definitely, we're going to have H3O plus ions. Here, we're going to have a basic or alkaline solution. And then here, we're going to have acidic solution. When acid, but now, when this react together, we're going to form salt. This is what I'm interested in, salt. So what's going to happen during neutralization, we're going to take this salt and we're going to react it with water. So when this salt react with water, that's when we mean by hydrolysis. That's hydrolysis, when salt reacts with water. Now, the purpose of us doing hydrolysis is to do what? Is to determine the pH of the solution, okay? Whether, I get it, look, when acid react with base, will the solution be acidic, or will solution be basic, or will solution be neutral? That's what is happening. When acid reacts with base, we're gonna form product, salt, whatever. But this solution could be basic. Depending on acid and base, which one, which acid, which base is reacted. Or the solution could be acidic. Or the solution could be neutral. So this depends on what acid and base has reacted this side. So if a strong acid reacts with a strong base, solution will be neutral. If a strong acid reacts with a weak base, who's gonna lead? Acid. Acid will be more dominant than the base, which does make sense. If turbo is tough than turbo, turbo will dominate turbo. It makes sense. So if you have a strong acid and a weak base, strong acid will overpower, then the solution will be acidic. If a weak acid reacts with a strong base, then solution will be basic or alkaline because the base, it is stronger than the acid. So, but when we perform the hydrolysis, we're going to focus on the salt. That's why here we say define the hydrolysis, the reaction of a salt with water. This is hydrolysis. Now, let me teach you how does hydrolysis work. I said to you, okay, let's take it from here. If you have a weak acid, it's what I told you, Shane. If you have a weak acid and a strong base, solution will be alkaline, meaning solution will be more than 7 because you have a strong base. Okay. For an example, if sodium ethanoate and whatever, okay, it's fine. And then if you have a strong acid, a weak base, solution will be acidic. pH will be less than 7. If you have a strong acid and a strong base, there will be no hydrolysis and the solution will be neutral. Then you're going to have pH of 7. Meaning salt, agree, like I said, acid will react with a base to form salt. So this salt won't go or won't be able to undergo hydrolysis if you have a strong acid, strong base. Therefore, there will be no hydrolysis, meaning this salt can't react with water at all because you used strong acid and strong base to form this salt. So the solution will be neutral. They will balance each other. Okay, so that's what we mean. So hydrolysis is the okay, we said that. So now let's come here. Acid and base we form salt. Now, if that salt, the salt that was formed, the salt here that we're gonna form, it was made by a strong acid and a weak base. Meaning, if you take a strong acid, you react it with a weak base, you form salt and water, of course. This salt, it was formed from a strong acid and a weak base, right? We say that the salt of a strong acid and a weak basic is acidic, which does make sense because you have a strong acid, therefore this salt will definitely be acidic. If you taste this water, when you taste the water will taste acidic, whereby the pH it is less than 7. But if you take your weak acid, you react it with a strong base, like I said, all the times, you're going to form salt and water. Sometimes you form carbon dioxide. Like I said, it depends on what acid and base is reacting here. But anyways, the main focus is the salt because you're talking about the hydrolysis. So this salt, it is made up of a weak acid and a strong base. Therefore, this salt will be alkaline, will be basic. Then when you taste that water, where you react acid and base, it's gonna taste basic, meaning the pH it is greater than 7. Therefore, this salt it is basic. But if you take a strong acid, you see, I'm repeating what I said. If you take a strong acid and a strong base, you're gonna form salt. But this salt is gonna be neutral. It won't taste basic. It won't taste acidic. By the way, we said this salt will not undergo hydrolysis. The salt of a strong acid and a strong base, the pH will be 7 of the solution. The pH will be 7 of the solution. And this salt it is neutral and no hydrolysis will take place. So I will end it here and then I will send another session for continuation.